A, B, C belong to integers union 0. Let me correct this. Positive integers union 0 because 0 is an integer. It means that A, B, C are non-negative integers. It could say that A, B, C are greater than equal 0 and they are integers. And 2 to the A plus 2 to the B plus 2 to the C equal to 160. Now we want to find A, B, and C. Okay. For first step, I want to factor. For example, look, when we have 2 to the 1, 2, for example, to the 4, 2 cubed, I can factor from 2, and it will be 1 plus 2 cubed plus 2 squared. So if I find the minimum one, I can factor. So because the problem is symmetric with respect to ABC, so I can say without loss of generality, suppose A is less than or equal B. Let me write like is because they are at least 0. Less than or equal B, less than or equal C. So and I have 2 to the A plus 2 to the B plus 2 to the C equal to 106. Because A is the minimum, I can factor from 2 to the A. It will be 1 plus 2 to the B minus A plus 2 to the C minus A equal to 106. Now, if B is greater than A, then we can say what? Let's factorize the prime factorize 160. It is 16 times 10, which is 32 times 5. 32 times 5, which is 2 to the 5 times 5. So let's consider B minus A here. I say case 1. If B minus A greater than 0 or greater than equal 1. We know that because B is C is greater than equal B, then C minus A also greater than equal 1. So in this case, if I write 2 to the A, 1 plus 2 to the B minus A plus 2 to the C minus A equal to 2 to the 5 times 5. This part will be even. This part even even plus 1 will be odd. This odd part times 2 to the A. So the only case is A equal to 5. So let's write A equal to 5 and 1 plus 2 to the B minus A plus 2 to the C minus A equal to 5. So because we know B minus A is at least 1, C minus A is at least 1, the only possible case is B minus A equal to 1, C minus A equal to 1. Then it will be 1 plus 2, which is 5. So here I conclude B minus A is 1, C minus A is 1. So I can say, let me erase this part to write the rest. So here I can conclude because A is 5, you can say B is A plus 1, which is 6, and C is also A plus 1, which is 6. So 5, 6, 6. If you check, 2 to the 5 plus 2 to the 6 plus 2 to the 6. It will be 32 plus 64 plus 64. 64 plus 64, 1 to 8. The sum of them will be 160. It works. So our first answer, let's write A, B, C. I want to gather all answers here. A is 5, B is 6, C is 6. But here I said without loss of generality, A less than or equal, B less than or equal C. I should consider all arrangements because the problem is symmetry with respect to A, B, C, 6, 6, 5. Now, let's consider case number 2. If B minus A equal to 0. Case 2. B minus A equal to 0, which is A equal to B. Now, if I write again our main equation, 2 to the A times 1 plus 2 to the B minus A plus 2 to the C minus A equal to 160, which is 2 to the 5 times 5. Because B equal to 0, so I can erase this part, and I can say it is 2 to the 0, which is 1. So it will be 2 to the A, 1 plus 1 plus 2, the C minus A equal to 2 to the 5 times 5. 1 plus 1 is 2, so 2 to the A times 2 plus 2c minus a equal 2 to the 5 times. Now I want to decide on this part. If c minus a equal to 0, then it will be 1. It's odd. Otherwise, it will be even, and I can divide by 2. So I should divide this case number 2 to two parts. We can say case 2, 1, c minus a equal to 0, which c equal to a. And if I replace 2 to the a times 2 plus 1, 2 to the 0 is 1, equal to 2 to the 5 times 5. Here it will be 3. But here I have 5, and it is impossible. Let's consider case 2, 2. In case 2, 2, c minus a is at least 1, so I divide both sides by 2. So let's call this one star. If I divide both sides by 2, it will be 2 to the a, 1 plus 2 to the c minus a minus 1 equal to 2 to the 5 times 5. And now, look this part. If this part is 0, then it will be 1 plus 1. 2 here, power of 2, impossible. Right hand side, we have 5. So, we can say it is odd part. And 1 plus 2 to the c minus a minus 1 should be 5. Because here we have 5, odd part. A is 5 also. A is 5. So, by using this, you can say 2 to the c minus a minus 1 equal to 5 minus 1, 4. So, we can conclude. Let me write it here. This is the rest of case 2, 2. See, because 4 is 2 squared, c minus a minus 1 will be 2. Also, a is 5. So here, c, take negative a and negative 1 to right side, it will be a plus 3. So c will be 5 plus 3, which is 8. Also, we know a equal to b. So, a equal to what? 5. Well, a equal to 5, so b equal to 5. Oh, I've made a small mistake here. I've divided by 2. I should change it to 4. So let's correct it. Here 2 to the 4. That's correct. And then here I only correct this. A equal to 4. And now let's erase this part, this part. Okay. So a equal to 4 and c equal to a plus 3. So c equal to 7 and b equal to a in case number 2 is set. So b equal to 4. Now let's check. 2 to the 4 plus 2 to the 4 plus 2 to the 7 equal to 16 plus 16 plus 1 to 8. 16 plus 16, 32. 32 plus 1 to 8 is 160. Okay. So 447 works, and I write 447 and all permutations. 4, 7, 4, and 7, 4, 4. So we found 6 answers for this problem. And let me write homework for you. Try to solve 2 to the a plus 2 to the b as homework, plus 2 to the c plus 2 to the d equal to 2, 0, 50. And a, b, c, d are integers. And also we can say a, b, c, d are greater than equal 0. And try to find a, b, c, d are what? And comment your answers below this video. And if you had other questions, you can send message to my WhatsApp number in the comments and description. And please don't forget to subscribe, turn on the bell, and like the video. Thanks. Bye.